Hello, happy people of the statistics world. This is your first video for your virtual day lessons in statistics. Before we had spring break, we talked about discrete random distributions, including the binomial distribution. So now we're going to move on to continuous random distributions. So we're going to talk about variables that can be decimals that go on forever. And the one distribution we're going to be talking about for continuous is the normal distribution. So how this is going to work is each day I'm just going to go through the slides I would have gone through with you in class and do the examples. And each lesson is shorter than normal, so hopefully that you can keep up with the work at home. So today we're going to talk about the normal distribution and whether a distribution is normal or not. So before we can talk about that, we need to actually talk about what the normal curve is and what the normal distribution looks like. So at this time, I would get out your notebook and I would pause the video so that you can write down the notes from this slide. And I'm going to pause for a second so you can do that. All right, so as you can see, the normal curve is bell-shaped and it's symmetric about the mean. That means the mean is in the middle, and that means each side, if it's symmetric, that means it's the same. So notice it's kind of like a mirror shape. It looks the same on each side. And the standard deviation controls how spread out it is. So if we have a small standard deviation, it's not that spread out. If we have a bigger standard deviation, it is more spread out. And in the future, when we talk about the mean and standard deviations, we're going to be talking about being a standard deviation, 2 standard deviations, or 3 standard deviations away from being the mean. So all of our data is under this curve. So that means all 100% of our probabilities fall under this curve. Another way to look at that is the proportion of the area under the curve. So if 100% of the probabilities are under the curve, that means the area under our curve is 1. So when we get to using tables and we talk about probabilities, all 100% of the probabilities are under the curve, and similarly, 1 is the total area under the curve. So we could either be looking at, think of it as finding the probability or the proportion of the area under the curve. And for the normal curve, our ends get really, really close to the x-axis, which is 0, but they never actually quite get there. So if our curve goes over the x-axis or it curves back up from the x-axis, it's not a normal curve. We're getting really, really close to 0, but not actually getting there. So if you've had pre-calc or calc, you know that the limit here would get really, really close to 0, would be 0 on each end. So that's what a normal curve is. So today, all we're going to do is we're going to look at different curves and tell whether or not they're normal. So again, I would take some time to sketch these 3 graphs, and I'm going to pause for a second, and so you can pause the video and do so. All right, so what we're going to do is we are going to look at each curve today, and we are going to determine whether or not it's normal. And if it's not, we're going to explain why. So the first one is, if we look at our first example here, our first example is not bell-shaped. So it has a high peak, but it's not bell-shaped and it's not symmetric. So we're going to say that no, this is not normal, and that's because it's not bell-shaped or symmetric. All right. So that's the first one. It's not symmetric. The second one is symmetric. It is bell-shaped, but if you look, it does go across the x-axis. And we talked about on the last slide how a normal curve approaches the x-axis, approaches 0, but never crosses. So the second one is also no, and it crosses the x-axis. Ah. All right. The last one, if we look at it, is bell-shaped. It approaches the x-axis. It's symmetrical. So this one is, in fact, a normal distribution. So we just have to say yes. So basically, when we're looking at normal distributions, we just have to make sure it's symmetrical, it's bell-shaped, and that it doesn't cross the x-axis, and that it approaches the x-axis, which the third one does. The second one crossed the x-axis, so it's not. And the first one is not bell-shaped or symmetrical. All right. So that should leave you with time to work on your homework. I hope you are safe. I hope you are healthy, and I hope you have a great day.